Am I audible? Okay. In last class I have discussed up to this one. Okay. So I am just starting from the next slide. Uh, this one. So I have discussed a little bit about this one, but I have not continued. Okay. So we study a more formal mathematical idea of what it means for a class to implement an abstract data type are the notion of abstraction function and invariant, means representation invariant. In short, read. Okay, so right now we know what is abstract data type. Okay, now how to implement this abstract data type, we have means we will discuss it further by means of a mathematical notation, and in that two terms are very important. One is abstraction function, another is representation invariant. Okay. Now, these mathematical notions are eminently practical in software design. Okay, so it's not a theoretical concept only. It's a very important thing in software design. Okay, so if you understand these things thoroughly, then software design will be more uh, simple for you. Otherwise, that will become very complicated for you. Okay, so uh, so it's not a theory only. Means, there are a lot of practical applications of this. Okay, later I will see. Later you will see that by means of an example, the abstraction function will give us a way to cleanly define the equality operation on an abstract data type. Okay, which we will discuss in more depth in future classes. Okay, and representation invariant will make it easier to catch bugs caused by a corrupted data structure. Okay, so the abstraction function will give us a way to clearly define the equality operations on an abstract data type. And these representation invariants help us to catch bugs caused by a corrupted data structure. Okay, so the use of these two are different. Now, invariance. What is meaning of invariance? So here we are talking about representation invariance. Invariance. So what is the invariance? Okay. Resuming our discussion on what makes a good abstract data type, the final and perhaps the most important property of a good abstract data type is that it preserves its own invariance. Okay, so in case of abstract data type, it preserves its own invariance. Okay, that is the most important property of a abstract data type. Okay, preserve its own invariance. Okay, what is invariance? An invariant is a property of a program that is always true for every possible runtime state of the program. Okay. So an invariant is a property of the program that is always true for every possible runtime state of the program. See, earlier you have seen that in case of abstract data type, it may be at different state. Okay. Now at different state, the invariant of abstract data type will have same value in all states. It will not vary. For that reason, it is known as invariant. Wait a minute. Wait a minute. Okay. Saying that the abstract data type preserve its own invariant means that the abstract data type is responsible for ensuring that its own invariant hold. It does not depend on good behavior from its client. Means what are the data type? Means what are the invariant in the abstract data type are? Those invariants value will not change whatever the client may do with that class. Means it does not depend upon the good behavior from the client who are using that class abstract data type. Okay, so it is ensuring that the invariant value will not change. Okay. So immutability is one of the crucial invariant that we have already encountered. Once created, the immutable object should always represent the same value for its entire lifetime. Okay. So earlier we have discussed immutability. So what I have told, string is a immutable class. Once you have created a string object, that object value will not change. If you want to change the value, you have to create another string object and where you can store the new value. You cannot change the value of string object once it is created. So immutability, so the string objects are immutable. Okay. So if any object is immutable, then that value is always invariant, whatever may be the state of the class. Okay, so we have already discussed immutability. So see here, if you don't consider immutability, means if you write a Twitter program like this, okay, see, public class tweet, then public string offer, then public string text, then public date timestamp. Okay, and here we are writing the constructor tweet, then string offer, string text, date timestamp. Then this offer, this text, this timestamp. Okay. Okay. So see here, if somebody tweet in a Twitter, two things are very important. Who is tweeting? Second one, that is the author. Second one, what that author is writing. And third one, at which time that person is putting that tweet. So if we want to create a object tweet, then that object have three data. Okay, one is author, second one is text, third one is timestamp. Okay, so is it clear? This class is clear to to you? How? Is it clear to you?
Yes, sir.
And okay, now next question is, how do we guarantee that these tweet objects are immutable? Okay, this must be immutable, because if you can change this, then that has no meaning. Means, if you have tweet something and somebody can change your tweet, then it cannot be your tweet. It should be somebody else. Okay, so tweet object must be immutable. Okay, so thus once a tweet is created, its author, message, and date can never be changed. Okay, so the first threat to immutability comes from the fact the client can, in fact, must directly access its fields. So nothing stopping us from writing code like this. Okay, suppose we are writing code like this. With T, we are creating an object T, and this object must be immutable. Okay, so as per our requirement, tweet T, then a new, then we are Ram is the author, then a message, okay, then date. New date means it is taking the system date at which moment Ram is commenting something. Then we can write for T, T dot author equal to Sam, means we have changed the author. So this T is mutable or immutable? If this is our class, okay, can we write this code? First question. Is it okay? Yes or no?
স্যার একবার কোডটা দেখাবেন? Yes, we can write that.
Okay, so very simple thing, because see the author is public. Okay, so easily we can write this P dot author equal to Sam.
Yes, sir.
So initial value of author for P was Ram. Okay, now it becomes Sam. So P is immutable or not?
Yes, sir, immutable. String is immutable.
P, I am talking about P. P is immutable or not?
Not.
So it is not immutable, it is mutable. Okay, we can change the value.
Yes, sir.
Okay, so it's not a immutable object. P is not a immutable object, but what we are saying that the Twitter object must be immutable. Okay, Twitter object must be immutable. Tweet objects are immutable. Okay, so here in this case, if you write code like this, then we cannot preserve the property. It becomes mutable. Okay, so what we have to do? We have to change the code. Okay, so this example is a trivial example of representation exposure. Exposure, meaning that code outside the class can modify the representation directly. Okay, so see, initial representation is RAM, then the message, this message, and then date. Now, outside the class, we can change the representation. Now it is Sam. Initially it was Ram. Okay, so this is known as representation exposure. Rep exposure like this threatens not only the invariants but also representation independence. Okay, it is threatening the invariance as well as uh, it is also threatening representation invariance independence. Okay, so see, Ram is tweeting something, and another person is changing the name to Sam. Okay, so one person representation is changing. That can be changed by a third person. Okay, so the thing is that so this is not acceptable. So first thing is it becomes mutable. Another thing is that it is not preserving representation independence. That must be there. Okay, suppose if you tweet something and another person later, if that person can change the name, okay, change the name of the author, then that representation is not proper, or that mechanism is not proper, or it is known as it is violating the representation independence. Okay, so fortunately, Java gives us a language mechanism to deal with this kind of representation exposure. Okay, so in Java there is some language level mechanisms are there by which we can deal with this type of representation exposure. Okay, so up to this it is clear to you.
Yes, sir.
What is the problem and means for what we are looking for, means this mutability and all these things, why you are looking for. Okay, so if we modify the code like this, in place of public string author, we are writing private final string author. Means here in the earlier code it is written, see, here it is public, public, public. Now here private final, private final, private final. Okay, we are changing this. Okay, so as it is private, we can access it inside the code, inside the class. So there is no problem. So we are accessing this within the constructor. Then we are writing this public string get author, return author. You can write that public string get text, return text, public date get timestamp, return timestamp. We can get date or timestamp. So is it clear? Means, can you do that?
Yes, sir.
Okay. So when in place of public, if you write private final, then what will be the change? Means what is the effect of that?
I cannot access all those variables outside the class.
Yes, that is due to private.
Yes, sir. And I can only initialize one time. I cannot re-initialize that part.
Means we cannot change it further.
Cannot change it because of final.
Yes, if it is a final, then we cannot at the time of creation we can set the value. Later we cannot change the value. Okay, so we cannot write, in this case we cannot write this one, a dot author equal to Sam, because it is private, so we cannot access it outside of the class. Author, we cannot access it outside of the class. To get the value of author, we can use this function get author to get the value of author, but we cannot change the value from outside of the class because it is private. Okay, and as it is final, after doing this, we cannot change its value. It becomes immutable. So is it clear to everybody?
Yes, sir.
To others, it is clear. Okay. Now, the private and public keywords indicates which fields and methods are accessible only within the class and which can be accessed from outside the class. Okay, so that everybody know. The final keyword also helps by guaranteeing that fields of this immutable type won't be reassigned after the object is constructed. Okay, but that is not the end of the story. The read is still exposed. Representation is still exposed. Consider the perfectly reasonable client code that uses tweet. Okay, so the problem is not yet over and the story is not yet over. That is not the end of the story. Okay, if you write code like this, that is not the end of the story. I am just giving another code. Perfectly okay client code. Public static, tweet, retweet letter, tweet t. Okay, then date b t dot get timestamp. Okay, so it is date b is taking the timestamp of this tweet. Okay, that is made by another person. Okay, so this is a tweet object t, and we are getting the timestamp, means reference of that timestamp to d. Then we are changing the hour. Suppose this timestamp is giving hour say 8. Now we are changing it to 9. Okay, then we are tweeting it again with a new name, Sam. Then p dot get text means earlier text we are getting, and we are getting a new time b. Okay, then we can create another tweet object and we can return it. So is it acceptable to you, or is there any confusion regarding this code? Hmm? Is it okay for everybody?
Yes, sir.
Okay, so what retweet letter takes a tweet and should return another tweet with the same message, p dot get text. So same message called as retweet, but sent an hour later. So the hour is 1 hour after this tweet. Okay, so retweet letter method might be a part of a system that automatically echoes funny things like that and what Twitter celebrity says. Okay, so problems are still there. Okay, problems are still there. So if you write code like this, still it is not immutable.
বাট স্যার এই ক্ষেত্রে তো নতুন অবজেক্ট বানাচ্ছে,
অবজেক্ট
ওই অবজেক্টটা তো এডিট করতে পারছে না,
কিন্তু ওই অবজেক্টের ডেট আর ওই অবজেক্টের টেক্সট সেটাকে তো ইউজ করতে পারছি।
শুধু গেটের মেথড নিয়েছি, গেট টেক্সট করছি, বাট টেক্সটটা সেট করতে পারছি না আমি, কিছু চেঞ্জ তো হচ্ছে না, টেক্সটটা
চেঞ্জ হচ্ছে না, কিন্তু আমি ধরো আমি একটা জিনিস বলছি, হ্যাঁ, সেটা আমার পারমিশন ছাড়া সেম জিনিসটা আবার রিপিট হচ্ছে উইথ এ নিউ অথার নেম আফটার 1 hour আফটার সে রিপিটেডলি এটা হতে থাকছে।
আচ্ছা,
ইজ ইট অ্যাকসেপ্টেবল? So for that reason, this is the problem. Okay, and another problem is that see this figure. See this figure. Here we are taking the reference of date. Okay, get timestamp means we are getting the reference of this. Okay, date means timestamp of t means this t. Okay, so we are getting the reference of this. Okay, see timestamp is pointing this, so we are getting this reference and same reference is assigned to D. Okay, then using D, we are changing the value. So initially suppose it was 11.36 and after adding 1 hour to this, it becomes 12.36. Okay, so is it acceptable? Once it is created, this T is created, those values means any of these values, author, text or timestamp cannot be changed. Then here you can change that. So is it acceptable or is it immutable? It's not. It's not immutable. So it's immutable again. Okay. So there is a problem. So this code is better than this one, but still this code have some problem. Okay. And this is not 100% immutable. Better than earlier one, but it's not foolproof. We can do this. Okay, so what is the problem here? The get timestamp call returns a reference to the same date object record by with T. T dot timestamp and D are alleles to the same mutable object. So when that date object is mutated by D dot set hours, D dot set hours means here, okay, D dot set hours, this affects the date in T as well as shown in the snapshot diagram. Okay, as shown in the diagram. 1 minute. Okay, so are you agree that there is a problem? It's still not immutable. Okay, so means your confusion is over. Means why we are means is, why there is means what is the problem here?
but sir, there is no set hours method defined in that class. So how I am using that d dot set hours?
So you can just write a set hours method.
Okay.
That method is too simple. For that reason, I have not written that. Okay, you can write your set hours method.
Okay.
Okay. Now, its immutability invariant has been broken. The problem is that it leaks out a reference to a mutable object that its immutability dependent on. Okay, we export the representation in such a way that tweet can no longer guarantee that its objects are immutable. Perfectly reasonable client code created in a subtle bug. Okay, we can patch this kind of representation exposure by using the defensive copy, making a copy of mutable object to avoid leaking out the references to the representation. Here is the code. Okay, so public date get timestamp return new date dot get time. Okay, we are creating a new object and then we are sending the reference of that new object in return. Earlier, what we have done? Earlier, we have returned the same object reference. Okay, so for that reason, if we are leaking the reference of a mutable object, using that reference, we can change its value. Okay, but if you make a separate copy here, and if you return that copy, then when we will work with the reference, then the initial value will remain unchanged, and we can work with the new one when you are changing any value. Okay, so this is the code. Means we should not leak any reference to a mutable variable. Okay, see, there is no problem for these two because see, this first one is author and second one is that text. Both are string, so both are immutable. If you send the reference back, using that reference, we cannot change the string value because it is already immutable. But date is not a immutable object. Date is a mutable object, so you can change its value. Okay. Okay. So up to this, it is clear? No. Yes. Up to this. Is it clear to everybody? Okay. Now, mutable types often have a copy constructor that allows you to make a new instance that duplicates the value of an existing instance. In this case, date copy constructor uses the time value measured in milliseconds since January 1st, 1970. As author, another example, string builder's copy constructor take a string. Another way to copy a mutable object is clone, which is supported by some type but not all. There are unfortunate problems with the way clone works in Java. Okay, so copy constructor is there, then clone is there. Okay, so but unfortunately we should not use clone in Java because there may be various problems. Okay, so we have done some defensive copying in the return value of get timestamp, but we are not done yet. There is still representation exposure. Consider this. Again, perfectly reasonable client code. Okay, so still the story is not yet over. Means there is still bug inside your program. Okay, so this is, if you do this is not sufficient. Okay, so there may be some problem still. Okay, so see here, public static list tweet every hour today. Okay, list tweet new array tweet get date new date, then means every hour it is starting from 0 at less than 24 means 23 up to 23. Date dot set hours I means for I equal to 0 set hours is 0, I equal to 1 set hours becomes 1 in that way. And in the list we are adding tweets. Okay, we are creating 24 tweets and we are adding them into the list. Okay, and then after that we are returning the list. Okay, so this is a perfectly reasonable code. We are using this. We are using this class. This class, okay. And we have changed this one, and we in place of this get timestamp method, we are using this method. We are using this method, and then after we are writing this code. Okay, but still there is a problem. Okay, now what may be the problem? Can you identify that? Here we are doing 24 tweets. Okay, per day 24 tweets, and per hour one tweet. What may be the problem? And we are adding those tweets into a list. The tweet is keep it up, you can do this, do it. This is done by Sam. Every hour, this tweet is appearing. What may be the problem in this case? And we are putting this tweet into a list of tweet objects.
লিস্টটা তো মিউটেবল, লিস্টটা তো ইমিউটেবল না।
না, সেটা প্রবলেম না, আমরা লিস্টটাকে খালি অ্যাড করছি। প্রবলেম ইজ উইথ টুইট। লিস্টের অবজেক্ট গুলো মিউটেবল হলে মিন্স ইমিউটেবল হলে লিস্টে আমি কি অ্যাড করছি না করছি সেটা তো কোনো ম্যাটার করে না। লিস্টটা তো অবশ্যই ইমিউটেবল হতে হবে, নাহলে লিস্টে অ্যাড করবে কি করে? লিস্টটা যদি at the time of creation of the list is empty, so later on you can add element into the list, you can remove element from the list. So if list is immutable, then how you can do that? So list is always mutable. লিস্টটা ইমিউটেবল করলে তো লিস্টটা কাজই করবে না। Okay, it is. So all each object in the list is working with the same date. Okay, see here we are creating one date object and we are using that date and we are changing the value of that date object. Okay, so initially the date value is 0, hours is 0, then it becomes 1, then it becomes 2, then it becomes 3, in that way. So see here, and all these tweet objects is sharing the same date. So Initially it is 0, then it becomes 1, then it becomes 2, then it becomes 3, ultimately it becomes 23. But you are thinking of that the first quit object having a date 0, second quit object having a date 1, like this, and last one having a date 23, means hour 23. Okay, but actually after running this loop, okay, all quit objects having value 23, date value 23. This will happen. This is the problem. Again, it becomes mutable. One type of mutation may occur. Okay, this is not the correct code. Okay, so this code intends to advance a single date object to the 24 hours of a day, creating a tweet for every hour. But notice that the constructor of tweet saves the reference that was passed in. So all 24 tweets objects end up with the same time as shown in the diagram. Okay, as shown in the previous diagram. Again, the immutability of it has been highlighted, so we can fix this problem too by using judicious defensive copying, this time in the constructor. Okay, so see, we have to modify the constructor. Here we will not pass the reference of timestamp. We will create each time a constructor will be called. We will create a new date, and reference of that date will be passed. Okay, so earlier constructor is like this. See, this timestamp equal to timestamp. Here we are writing this timestamp equal to new date timestamp dot get time. Okay. So in general, what you can say from this text example, you can say you should carefully inspect the argument types and return types of all your ADT operations. If any of these types are mutable, make sure your implementation does not return direct reference to its representation. Doing that creates a representation exposure. Okay, you are thinking that my object is immutable, but it's not. Okay, yes. You are sending a reference of a mutable object to the client, and client is using that facility to change the value. Okay, or that may be a bug inside your program. Okay, and the client can use that bug. Okay, so you are quite happy with this type of code. Suppose you are quite happy with this type of code. Okay, but this is not a proper code, or this is not a good code from security point of view. Okay. So a even better solution is to prefer immutable types. Okay, so in place of mutable types like date. You can use mutable type if we had used an immutable date object like java dot time zone date time instead of mutable java util dot date. Okay, then we could have ended this section after talking about public and private. Okay, no further representation exposure would have been possible. So if you use instead of date Java util date, if you use this Java time zone time date. Okay, so this is a immutable object where date is mutable. So if we use this in place of this, then we don't have to think about any code after this. If you just make the private a public as private, then that is the end of the story. So instead of this date, use immutable zone time date. That's all. Okay, you don't have to think about later code, what I have discussed. Only converting public to private is sufficient to maintain immutability. Other things, these things will not arise in case of immutable object. Okay, so this may be one way of avoiding complexity. Okay. Now another thing is that immutable wrappers around mutable data type. Okay. Java collections classes offer an interesting compromise. Immutable wrappers. Okay. Collections unmodifiable list takes a mutable list and wraps it with an object that looks like a list but whose mutators are visible, like set, add, remove, throws exception. Okay, so you can construct a list using mutators, then seal it up with an unmodifiable wrapper and throw away your reference to the original mutable list. Okay, and get an immutable list. Okay, so in Java that facility is also there. You can create a list with mutable object. Okay, you can create a list. What I have told, that list is always mutable. Okay, then wrap it with a unmutable class. Okay, immutable class, not unmutable, immutable class. Okay, so if you do that, then what you are doing in the list, there is set method, there is add method, there is remove method. So if you call this method after wrapping it uh, with a class, unmodifiable list class, then if you try to call this method, means by this method you can change the list. So if you try to call this method will generate exception, throws exception. Okay. Now, so after this it is clear, immutability. Clear to all, or having any doubt? Have any doubt? Any doubt to anyone? Okay. So representation invariant and abstraction function. Okay. We now take a deeper look in the theory underlying abstract data type. If you understand the theory deeply, you will be able to build better abstract type and will be less likely to fall into subtle traps. Okay. So if you can understand this properly, you can write good code. Otherwise, your code may be faulty. Okay. In thinking about the abstract type, it helps to consider the relationship between two spaces of values. Okay, there are two spaces of values. Okay, the space for representation values or read values for short consists of values of actual implementation of entities. Okay, in simple cases, an abstract type will be implemented as a single object, but more commonly, a small network of objects is needed so that these values is actually often something rather complicated. For now, though, it will suffice to view it simply as a mathematical value. Okay, so there are two values. Okay, two types of value of any implementation. Let's see mathematical from the mathematics point of view. The space of abstract values consists of values that type is designed to support. There are a figment of our imagination. They are Platonic entities that do not exist as described, but they are the way we want to view the element of abstract type as the client of the type. For example, an abstract type or an unbounded integer might have mathematical integer as its abstract value space. The fact that might be implemented as an array of primitive bounded integers, say, it's not relevant to the user of that type. Okay. Now, of course, the implementer of the abstract type must be interested in the representation values, since it is the implementer's job to achieve the illusion of the abstract value space using the representation value space. Okay, so we are seeing the object as an abstract value. Okay, but actually those objects are stored as a representation value inside the computer. Okay, so abstract value is the type of values which is designed to support, but actual thing, the representation may be completely different from that. Okay, I think it is better to give one example, otherwise it becomes complicated. Suppose, for example, that you choose to use a string to represent a set of characters. You can do that. String represents a set of characters. So we can write this. Okay. Then the representation space R contains string and the abstract space A is mathematical sets of characters. Okay. So see here, we are representing it like this. Okay, but abstract space is this set of characters. So there are two spaces. We are representing it like this. Okay, but abstract space is this. So if you represent it like this, it is in the abstract space. The thing is this: is a set of characters means that contains now. If in the representation space the values are string value is A, B, C, so it is a set of character A, comma B, comma C in the abstract space. In the representation space, the value is B, A, C. In the abstract space, it is A, B, C. Okay, see here, more than one representation can be represented in the abstract space by a single abstract set. Okay, and if the value gets repeated, A, B, B, C, then we don't have any abstract representation for that, abstract value for that. For duplicate, if there is duplicate character, then there will be no value. This is for this program only. Okay, so we can show two value space graphically with an arc from the representation value to the abstract value it represents. Okay, so there are some properties. Every abstract value is mapped to by some representation value. So see here, abstract value is this, that is mapped to some representation value. Abstract value is this, that is mapped to more than one representation value. Okay, so the purpose of implementing the abstract type is to support the operations on abstract values. Presumably, then we will need to be able to create and manipulate all possible abstract values, and they must therefore be representative. Some abstract values are mapped to by more than one representation value. Okay. Some abstract values are mapped to by more than one representation value. So see, some abstract value, not all. So this is representation represented by one value, but this abstract value is represented by more than one value. See, first property was the abstract value. For every abstract value, there will be a representation value, one representation value or more. And here we are saying that the some abstract value may have more than one representation value. See, second one. And third one, not all representation value are mapped. See, the last representation value are not mapped to the abstract value. Okay, so in this case, the string ABCD is not mapped. In this case, we have decided that the string should contain duplicates. Okay. Now we will come to the abstraction function and read invariants. Okay. So here, see, I have started with these two. See, abstraction function and representation invariant. Now I am coming to that. What is abstraction function and what is representation invariance? read invariant. So abstraction function that maps representation value to the abstract value they represent. Okay, so abstraction function AF is converting R to A. The arcs in the diagram shows the abstraction function. So in this diagram, the arcs is converting R into A. So these are representing abstraction function. Arrow. These are functions which convert R into A. Okay. And read invariant that maps representation value to booleans. Okay, so representation value to booleans. For representation value R, representation read invariant R is true if and only if R is mapped by an abstraction function. Okay, so what is the meaning of that? See in the diagram, suppose for an abstract thing, we are having a abstract function. Okay, in that case, the means for an representation, we are having a abstract function. For that, the Ri, that is the read invariant, see here, read invariant Ri will return true. Okay. For a representation value R, if there is any abstract function, then this Ri R will return true. If there is no abstract function like this A, B, B, C, in that case it will return false. Ri will return false. So is it clear that what is abstraction function and what is read invariant? Is it clear? Okay. Now both these read invariant and abstraction function both should be coded inside the program. Okay. So both representation invariant and abstraction functions should be documented in the code. So this code, what we have written, the simple code what we have written over here, that code can be modified like this. Private string is that representation invariant will be there. Okay. S contains no repeated character. Okay, so if S contains no repeated character, then there will be a abstraction function and it will return true. If there is some repeated character, then it will return false. Okay, so see here in the diagram, in this representation, if this representation contain any of the representation contain say repeated character, then it will return true. Sorry, it will return false. If there is no repeated character, then it will return true. Ri, representation invariant. Okay, so we have to code like this. An abstraction function represents the set of characters found in S. Okay, so see what is abstraction function. So if you want to generate this set of characters, what you will do? You will take the character from this string and that will form the set of characters over here. ADC. Okay. So this is the end of this chapter. Okay. Now see your syllabus. Hmm. One. So see the first chapter. Abstract data type and their specification, how to implement an abstract data type, concrete state space, concrete invariant, abstraction function, implementation operations, illustrated by the test example. Okay, so I think I have covered each and every topic of this syllabus. Okay. If you have any question, you can ask. This chapter is little bit complicated. For that reason, I have not discussed this one at the very beginning. Otherwise, there will be a lot of problem. And in this chapter, I have used some angular bracket. Okay, at the heat example, then other example, I have used angular bracket and how to do that program. That will be discussed in this chapter. That is the next chapter. That is generic type and collections. Okay. It will be better if I discuss this generic type and collections first, then this one abstract data type, but not a very big issue. So later I can discuss generic type so that you can just understand the program uh, of meaning of that angular bracket. That's all. Okay. So in the next object-oriented programming class, I will discuss generic type and collections. Okay. So any question, any doubt from anybody? Is it becoming too tough for you? I'm not getting any response from anybody. So for that reason, these questions from anybody. I'm getting response, but I'm not getting any questions from anybody. Is it becoming too complicated for you? And I am not getting any questions from the present class, means present topic, or I am not getting any questions from previous topics. Okay, so what is the problem? I don't know. starting with class or you are not starting with class? Or are you starting at, yes? But if you study, there must be some question. If you study, then there will be lot of queries. Means lot of doubt will be there. Lot of queries will be there. Okay, but you are not asking anything. Means most of the time. Most of the time, I am talking and you are listening. And whether you are understanding or not, I am not getting that feeling. In case of offline class, I can see you. Means I can see your face. I can see your body language. From that, we can understand that means what whether you are understanding or not. But in the case of online class, unless you communicate, we cannot understand that what is going on, whether you are understanding or not. Any problem? Any problem from anybody? Any problem from anybody? Any question from anybody? Okay, then I am closing this class.
ठीक भाई, क्वेश्चन वोश्चन पूछ लेना है किसी को।